Perhaps the best way of differentiating linear models which belong to the probability demon realm and causal models which belong to the causality demon realm is by showing examples in which a linear model cannot be a causal model. So let's take this example. We've got the variable practice as a causal variable and age as a consequence variable. So this model is saying that the more you practice, the higher your age. Now let's transform this into a linear model. Can we do it as a linear model? No problem whatsoever. We put age as variable y, practice as variable x, and there is absolutely no problem because we've got numbers for age, we've got numbers for practice, and based on those numbers we use the machinery of the linear models and mathematics to estimate the beta 0 and beta 1 in the hypothetical population of numbers. So there is no problem. However, the causal model is not a causal model. That is not possible, because no matter how hard you try, you practice, you cannot change your age. I try hard to be as old as my older siblings, but I never catch them. And my younger sibling didn't catch me either. You cannot put that as a causal model. Practice causing age is an impossible causal model. So yes, linear model, that's okay. You can predict, if you want to predict age based on the hours of practice that people accumulated in life, there's no problem. You can do that, and some research is about prediction. It's not about establishing causal relationships. So in that case, you can run your linear model, but do not make any causality interpretation of the results. And I give you an example that is probably more important, because in this case, you wouldn't, nobody would put forward this causal model that practice affects your age. But what about age as a causal variable? Age modifies performance, affects performance, causes performance. Of course, linear model, no problem whatsoever. We've got numbers for age, we've got numbers for performance. We use the machinery of linear models and mathematics, and we estimate the beta 0 and the beta 1, etc. But what about as a causal model? Does it work? Well, we've got a lot of instances in which an increase on age increases performance, is associated with an increase in performance. So, for example, in working memory capacity, that increases with age when you are a child, but up to the age of 15, 16, 17, 20, and then it starts to decline. So there is a relationship between age and performance. You change your age, that changes your performance, in this case working memory capacity. Same with sports. When you are a child, you increase in performance, your skills get better, and until some point, and then that reduces it. Now, you may think, well, this is not a line, this is a curve. It goes up and then down. Well, you can, by using some tricks, like generating a variable that's x squared, so you square the values of x, then you can create a curve with a linear model. But we are not going to go through that. What I want to show you is that even though there is a relationship between age and performance, and it seems that the causal link is correct, this is not an ideal causal model, because age is not the causal agent. So what changes performance? What causes the change of performance? Well, in the case of working memory capacity, is the brain maturation or the brain the connectivity. That is what changes with age, and in turn changes performance. So the causal agent is the change in brain characteristics like maturation or connectivity. Same with sports. Muscle mass changes, and that increases performance. It's not the age. So this type of model is as a causal model is not ideal. Some people propose this type of models, but I prefer that we use the actual agents. Now, for example, let's say that we want to investigate the causality, what causes performance, and we know that age is associated with brain maturation. Well, we put brain maturation as the causal variable, but then in the linear model we use age, because we use it as a proxy of brain maturation, and that's because we have technical difficulties. We don't have the resources to measure brain maturation, but because in previous research it was shown that there is a relationship, well, we use age as a proxy. So I would put it as a linear model. I put age, and we in the text we say that is the way we implement the causal model in this particular research. But age in itself is not a causal variable. So now again, not every research is trying to establish causality. We may want to predict the performance of people based on their age, and that's absolutely fine. We do a linear model with that. But when we do that, we cannot make interpretations in terms of causality. We cannot say that the increase in age causes the increase in performance. Now, that's the route that a lot of researchers are following, to decide not to use causal models in order to avoid the problem of establishing or making a causal interpretation of the relationship between variables. So they just say, well, there is a relationship, and they stop there. What I'm proposing is, no, we need to propose causal models, and we need to propose causal models that make sense. And then we test them with the strengths of the relationship with the variables, which will be, in this case, the beta 1. That's what we are going to estimate with the linear model.